today, we're gonna do the review as you guys would like. We're gonna have a review guide, and at the end of the review guide, and you'll get a, I'll just get you a hard copy of this, and we're going to, start from maybe from the beginning, right? Maybe from the beginning. Okay, review guide. All right, from the beginning. Okay, from the beginning. I mean, the 6 principles, the 6 mathematical principles. The 6 mathematical principles, they're being covered at the beginning, okay? And we have talked about every aspect of it. And throughout the semester, we use them over and over again in many different places. So this is really very, very important. I couldn't emphasize more about it, okay? So make sure you really understand these mathematical principles. Every time you use it, you are aware of it, okay? And then of course, later on, we talk about the truth table. The truth table. To me, these are the foundations. These are the foundations. Okay, these are the foundations of everything we built. Okay, everything we built. And next, the concepts, right? The concepts, which is on notes. The concepts on the second page, such as functions, right? What is a function, right? What is a function? And other definitions such as one-to-one function. Okay, one-to-one function. As a student, when we were doing math, in a lot of cases, we don't pay attention to these concepts. But you must, okay? You must. You'll realize how much time it will save you just to understand these concepts, and as they are applied to everything we do. That's why these concepts are placed at the beginning of the notes. Increasing, decreasing, okay? Even, odd, right? Even function, odd function. We don't have a whole lot of concept here in this, but these are the concepts that we have studied, and we've been studying them throughout the semester. Okay, so by this time, you should be able to, if you want to check your knowledge base, how well you are prepared for calculus, so one of the things you can check is quiz number 1. In the notes, okay, not the quiz that in our assignment, okay. Quiz number 1 will give you. I'm sorry, excuse me. Okay, quiz number 1 should give you a good check on how well you prepared for your calculus class. Okay. You should be able to answer every question. Okay, you should be able to answer every question by now. Okay, and they should appear pretty easy for you. They should appear pretty easy for you. Okay, so quiz number 1 is a check, and as I told you, the source of that quiz actually is from a calculus textbook, and it may not be in the latest version, but it was in some version of the calculus textbook. Okay, by the way, the last quiz was, given to you for your extra credit. Okay, this is the last opportunity for earning extra credit on quizzes. Okay, you will have some extra credit on the exam as well. Okay, on the final exam. Okay, so right now I want you guys to look at the notes. Okay, so please look at the notes. Let me show you what I meant. Okay, so this is the notes. Let me share that. Okay. Maybe I would just go over the notes with you guys. Okay, mathematical principles. You guys see that? You should look at the notes, right? So we can make some markings on these, right? These mathematical principles, to me, as a teacher, the first page is the most important thing. Most important. Okay. Why they're important? Because they lay the foundation. They are the building blocks. Okay. This guarantees that you build your house, you build your foundation on the rock. Okay, on the rock. And these concepts I just mentioned, right? All these definitions that are put on the second page, they're just as important as the first page and the truth table. For me, when I arrange these orders, okay, I arrange them by the level of importance. And here's the quiz number 1. You should be able to answer every question well, correctly, and efficiently. And you know what you're talking about, okay? And these are, extra exercises I collected over time. And next, basic 1. We know that everything we have built this semester, everything we have reviewed, is about these 22 basic functions. Okay, and they're all in the category of definition have indicated right here, function. Function. Okay, and what's domain and range about these functions? They are the very foundation. Okay, for your calculus classes, you're gonna see them again. Okay, in various forms. They will be. Some of them will be probably more complicated, and there will be some kind of composition or adding, subtracting, multiplying, dividing composition of these basic functions, right? But you're going to see these functions. And in fact, we've been studying these functions throughout the semester, okay? And now you should be able to answer these questions like, is it 1 to 1? Is it increasing, decreasing, even, odd, or neither, so on and so forth, okay? And in particular, this semester, I have changed my notes from last semester that for each one of these functions, we have studied them in detail. Okay, we have studied in detail. So I'm gonna go back to write something about the basic 1 table, right? Functions. Basics 1, okay? This is the absolute foundation about function. Okay, we studied every function. Was studied. All right, domain, range, examined, intercepts, EP, intercepts, graph, right? And which function will show up first in your calculus classes. So all of those indicators. So we studied every function in our, at the beginning of the semester, every one of them, okay? Including, later on, we study their transformation, right? Opening wider, opening more narrow, right? shifting left, shifting right, shifting up, shifting down. So all of these elements being studied. And we find that they have very similar features, right? How we express them, right? And we also, we use the function notation extensively. All right, so let's go back here. So all of these functions, right? Notes. Okay, so all of these functions, there are many, many pages that I'm sure in your notes, you've been filling in the blank, right? In particular, this relationship. We have studied this very much. Why? Right, why it is so, and piecewise functions, and how we turn this into, which much later in our semester, we've studied how the piecewise function, when x is turning into bologna, how it's been turned into its equivalent piecewise form. And you will need those forms, okay? You need those forms. So keep going on the list of our notes, right? With all these functions, all these, you know, we can see that these are just examples of functions. They are all under the one umbrella, which is a function. Of course, some of them are one-to-one, some of them are not. And so we have many, many pages about these. Okay, so those are the basics, right? Sometimes we have students come to the teachers, professors, and they ask, what are you going to test us, right? What are you going to be testing us on? And the professor typically would tell you, I will be testing you on the basic concept. And when you look at the test and said, well, this is not a basic concept. Well, you just didn't realize they are, okay? And the professor can tell you, oh, you can see this is testing about this concept, this is testing about that concept, and so on and so forth. So you have to absolutely study those concepts. So when you look at the question, you can see how those basic concepts are related to the question you're working on, okay? So going further, okay, the first set, right, basic 4 through basic 7A, okay, basic 4. So now we're gonna start, we can study by blocks, okay? ABS, absolute value, okay, absolute value related. Absolute value related, okay? Basics 4. Basics 4 through basics 7A. Make the font just a little bit smaller, okay? Basic 4 through basic 7A. These are absolute value related, okay? And they're if statement, of course. What is the statement? The statement was studied in one of the functions, the function, right? So one of the functions we studied in basic 1 was absolute value. The absolute value function. Okay, let me just keep it simple. This function. Right? It turned into different forms. A statement, if statement, and so on and so forth. Basic 4 through basic 7A, they're just if statements. And here is the statement. And that statement turned into various form on the if situation. So statements, if statements, okay? Including the inequalities, We talk about the cases, right? The absolute value less than, greater than, equal to, all these under the umbrella of if statements, right? The graph, the solution, okay? And special cases, right? Sometimes the absolute value is larger than a negative number. or smaller than a negative number. So larger than 0, greater than 0, and so on and so forth. So greater than equal to 0. All these cases are being covered. Okay, all of these cases being covered. Okay, so are you guys still looking at the notes? Okay, so I do want you to look at the notes. And what I have here, I have two screens in front of me. So if you are looking at the notes at the same time, so I don't have to alternate between these two. Would that be okay with you guys? Okay, so here, right here, I inserted a trig 1. Okay, of course, trig is another block, but trig 1 here was inserted here. It just to poke you about what you have studied, okay, in that order. Of course, we already answered those questions about domain and range, okay? And then the next set is about quadratic. Okay, the next major study is about quadratic. Okay, quadratic. Okay, quadratic, there's a function, there's an if statement based on that function. And I have read, I don't know how many of you read the Everything Quadratic that was posted in the module. And so from quadratic 1 through okay, all these has something to do with quadratic, right? All the way, we have axis, we have quadratic opened up, go down, touch it, touch the curve once, touch the curve twice, touch the curve and no times. We have all of these cases covered. We have all of these cases covered. You've seen those examples, right? Quadratic 1 through, I would say, quadratic 17. They're all about the transformed quadratic, right? Transformed, right? This is the basic function. It's transformed into ax squared plus bx plus c, where a is not 0. You see that transformation, right? It's like turning into a butterfly. Okay, turning into a butterfly. And of course, that's the function we studied extensively. We studied that function, we studied extensively, okay? A statement, an if statement. We did the vertical cut, horizontal cut. We did lots of examples in those sections, okay? Completing square, right? And later on, when we were doing trig and we were doing logarithm, exponential, we see quadratic function show up again, right? Quadratic function, quadratic equation, the if statement show up over and over again. So this is a very important topics, very important topic. So you have all the cases, okay? The cases, right? All the cases. But how many cases are there after all? There are only 3 cases. There are only 3 cases. Okay, there are really 3 cases. Okay, in terms of opening, well, you opening up, opening down, right? And we typically classify this as just 3 cases. Okay, the parabola. Okay, crosses x-axis twice. The other case is it crosses how many times? Once. And the case number 3, it crosses no time. Open up, open down. It could be opening up, it could be open down, okay? It could be open up or down, right? All these cases studied. Open up, open down, okay? It could be opening up, it could be open down. If you look at all the cases we have there, every case, okay, if you've done enough exercise, you found there's just these cases, three major cases, okay? And they can all be foretold. They can all be foretold by 4 squared minus 4ac. In the first case, is larger than 0. In those second case, and this quantity we call discriminant is magical. It's a magical quantity. It tells us so much about opens up. It tells us so much about how many times it crosses x-axis. Okay. And it also tells us a lot about factoring, that quadratic formula, right? Quadratic formula, it gives us the factors as we have addressed later, completing a square, all of that stuff. Okay, so everything about quadratic is really all condensed, okay, all condensed into this piece. Okay, if anything, you should understand these, okay? And of course, you're looking at details, there's some algebraic techniques that's required. So that's quadratic, okay, quadratic. So all the way up to quadratic 7. The next category, of course, in quadratic, we not only, and there's all these if statements, right, about quadratic. The if statements, right? What are the if statements? Larger than 0, right? If larger than 0, blah, 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 right? If smaller than 0, right? If equal to 0, just these 3 cases, they combine in different forms, the if statements. And we can tell, okay? We can tell by, b squared minus for AC, lots of information can be gathered. You can do factoring, you can do all sorts of things. They're all related to these b squared minus 4ac somehow, okay? Right? Inequality. And then we have that basic 9. Inequality. So there's an overlap here, okay? There overlap. Inequalities. Okay, inequalities. You look at these questions as basics 9, right? Quadratic inequalities. Basic 9, that overlaps with the inequalities in quadratic, okay? And basic 10, quotient. Okay, how do we solve those inequalities, right? How do we solve those inequalities? So there's some overlap between this block and that block. In addition, we have the quotients, right? Rational function, what you call the rational function. How do you solve those inequalities at basic 10? Okay, and there's 10A, 10B, 10C, and we'll give 10D, E. I give you lots of exercise there, but it's optional for you guys to do. If you really want to be so good, just do more of it. Okay, you don't have to buy another book. Okay, hopefully save you money right there, right? So inequalities. These ideas of solving them we have talked about the use of mathematical principles in the process, right? Positive, and the same idea about, you know, the if statement, larger than 0, less than 0, equal to 0, is portable, right? It's portable. How was it portable? Where did we transport them? We transport them to other functions such as sine, cosines, you know, trig functions, exponential functions, logarithm functions, isn't it? Didn't we? Right? The ideas are the same. Right? It's all about input output. Throughout the semester, we talk about input output if statement, right? Input output if statement. That's all there is, right? Is that right? So if you just focus on input output function, everything you see from the lenses of the function concept, input output if statement, it's very, very much streamlined, Of course, there are some technical algebraic techniques that you need to be able to work out. But conceptually, we should have a crystal clear about what is that fundamental ideas that going through all of these very varied forms of functions. Okay, so keep going, and we have some exercise in between. Okay, even if I didn't mention them, those are in preparation for your work. Okay, so don't ignore them. Do go through them. Okay, do go through them. For example, basic 18. We didn't spend much time there because I assume you guys know it. Will question like basic 18 be used in your calculus class? Yes, absolutely. To find a tangent line to a curve, right? You are expected to know it. You're expected to know it. Okay, perpendicular, parallel, and all of that stuff. So we didn't spend much time on some of those things. I assumed, okay, but I could be wrong. Okay, sometimes I assume that it would be easy for you. So we didn't spend much time in class. Okay. So such as basic 18, right? So there's some prep exercise. Okay, prep exercise such as basics 11 through basics 18. Okay, and another piece of important exercise is basic 19A. And of course, you expect there's basic 19B and so on and so forth. This is a group of exercise to determine domain and range. I'm sorry, just to determine domain. Excuse me, just to determine domain. Okay, these exercises are actually many of these are actually from your calculus textbook. Okay, so we've been there and you should know how to decide. And some of these questions, as you've seen, show up on your midterm, and some of the questions may show up on your final exam, okay? So I give you lots of exercises and basic 19, 19A, 19B, 19C, and only require you to do A. If you want to do more, hey, go for it, right? You get to solve those inequalities, right? You get to solve those inequalities, right? And those inequalities end up taking you back to where? Back to solving inequalities. Okay, you start to understand why I call them basics. Okay, so these, now, trigonometry. This is, by the time you get to the trigonometry pages, and this is like a revisit. This is more like a revisit, right? Because we did a trig functions in basic 1, right? We talk about all those other issues. So you get to practice, right? Domain range again, right? A lot of these are just repeats. A lot of these are repeat. So this is repeat. The first The first time you do trig, we do trig is in basic 1, right? We did a graph, we did all the detailed groundwork. And then you see trig, right? You see trig from trig 2, right? Through, and this is just reinforcement, okay? Graphing pictures and plotting points and proving identities and so on and so forth. So if you go through the pages on trigonometry, all the way up to trig, I would say trig 8, trig 9, trig 10, trig 11, trig 12A. Yeah, trig 12A. These are just re-examine, right? Re-examine trig functions from different perspective. Okay, as a function, domain range, what type of quantity is expected for, you know, remember the ARD, right? We talk about ARD very thoroughly. Sometimes you have A, you get to D. And sometimes you get D to A, right? And R is the bridge, reference angle. So everyone should know what ARD is. All the questions you're going to encounter related to trigonometry, they are all related to ARD. Okay, 3 letters. A, do you know what's A? Do you know what's A? Do you know what's R? Do you know what's D? Right, ARD. Okay, so we can, every question, every trig question you do, you think of ARD. Okay, all the function boxes we drew throughout the classes. We were trying to do that consistently. So you see consistency, how everything is derived from them. Okay, everything is derived from them, indeed, including solving inequalities at the end, like 12A, trig 12A, right? The perspective, the different perspective. Okay. All right, so that's trigonometry, big block. We spend a lot of time. Okay, we spend a lot of time. And the next big one is logarithm and exponential. Logarithm and exponential. And this, once again, we already did, you know, logarithm and exponential. It's just a revisit. It's just a revisit those functions, those curves, right? Those points, right? We plotted those points, right? Domain and range and inverse functions and so on and so forth. So how they're related, right? Each one of them, we spend, with the basic one, we study log base 2, log base 10, and common log, you know, log base 2, common log, natural log. Natural log is something that we all need to transition to eventually in your calculus class. You rarely see other logarithm, you only see natural logarithm most of the time. Okay, it's rare for you to see other logarithm. So you need to understand that logarithm, the pictures very well, how to determine domain, how to find its inverse, and so on and so forth. Okay, so you have done the due diligence, which is what? Very basic. See it as a function, input, output, plot points, if statement, so on and so forth, right? Still always the same thing. Okay. And I wish you to think from those perspectives. What is a statement? Is this a statement or is this an if statement? Right? In the past, you probably have learned that expression, equation, right? Now we go furthermore, even more fundamental. It's just a statement or if statement. If statement is the equation, equation the if statement. expression is statement. Okay, it's just a statement. Description of certain operations. All right, revisiting logarithm exponential, of course, we got some more, right? The product rule, quotient rule, power rule, change of base formula, and all of that stuff, right? From definition, right? We should know definition very well, right? Log base of B, omega equals to triangle. You should be very familiar with these forms, right? You can invent your own forms using any symbol. No problem. Okay. No problem. Okay. And right next to it, we have derived, we derived and proved every one of those, right? And base raised to the power of log base B omega is equals to omega. And I told you you're going to use this, right? You're going to use this. Okay. I will keep my promise. Okay. If you never get to use this in your calculus class, come back to tell me. Okay. This is the one you're going to use in calc. Okay. Product rule, quotient rule. Okay. Quotient rule. Power rule, right? All these rules, and change your base formula. Right? That's all you have. That's all you have. Product and the common mistakes. Remember the common mistakes. Common mistakes. We talk about those common mistakes. We talk about the counterexample. So be mindful. Be mindful, okay? Product rule, quotient rule, power rules, right? There are common mistakes about them. I hope you guys will never make those common mistakes when you're in Cal. Okay. So on this logarithm part, I would say from log 1, right, through, and of course we have if statements, right? We have those if statements, lots of exercises, expanding, right, as single logarithm, and all the way up to log like 15, 16, something like that. And we did transformation. I would say log all the way up to 15, 16, 17, 18a. Log 18a. Along the way, exp1 through exp exponential, right? Exponential. We can't address logarithm without addressing exponential. exp3, right? exp1 through exp3, right? We've done them together, right? We've done them by pairs. And transformation, shifting up and down, left, right, over, right? We've done all of those. Yeah, so logarithm exp is a big piece. You guys will, we dealt with some of those interesting functions, right? If you look at absolute value of ln x, right? Some of the examples. we have lots of them, right? Examples such as the absolute value of ln x, right? And the other one would be the typical ones, right? ln x of absolute value, what's the difference? Right? And so on and so forth. We did many lectures and etc. Okay, domain range, all of these issues, right? Transformation. And all the way up to, you know, inequalities. Sometimes, you know, these are two big blocks, okay? Logarithm exponential is one big block. The other one big block is trig. And so by this time, we've done this the second time. This is really the second time we do it, revisit, right? And there are lots of content in there, So next, and the material gets a little easier, I would say, right? Because I told you at the beginning of the semester, we're gonna do the harder ones first. Okay, so we get to repeat them. Okay? So now basics, continue to review basic 21 through, these are functions, this is about power, right? Power. What are the powers? B to the power m times b to the power n, and so on and so forth. We have used them throughout. So basic 21 through, these are really the groundwork. It's just in preparation for stuff. And there's also shifting transformation there. We just didn't go over all of them because we think we have done enough to prepare you for you to do it yourself. But these are really, really very basics. Okay, all the way through basic 35A. Okay, and the 35A, at the 35A, we actually saw some practical questions you are going to encounter in Cal, right? In calculus classes. And I promise, okay, if you don't see any one of them show up on your calculus classes, then you should come back to tell me. I would appreciate it. Say, hey, Professor Wang, what we did in class, you told us we're going to have them in calculus class. I didn't see any one of them. That would be interesting. That would be very interesting. Okay, I would be totally surprised. Okay, so these are basic. In this blog, just go through those exercises. I would encourage you guys even do it in the summer. Right? If you're taking Cal in the fall, right? And there's more in the summer. Basics 36 and onward. This is about the fundamental theorem of algebra. In your calculus class, you will learn fundamental theorem of calculus in calculus 1, okay? So in this part, the major theorem here is really the basics of the fundamental theorem of, excuse me, I need some tea, algebra. It's a big title. Okay, there's serious lectures, remainder theorem, factor theorem, rational zero theorem, and so on and so forth. Things you will learn about factoring, evaluating functions. You shouldn't be surprised. You're going to use them again somewhere down the road. And this is about polynomial, because fundamental theorem of algebra is all about polynomial. You're going to see polynomial again. And of course, quadratic is a special polynomial, right? Linear is a special polynomial. And all of these theories, you want to understand and know them. That's why I list them there. We didn't spend a whole lot of time there though. we spent some time, but we didn't spend a lot of time like we spent on trig and logarithm. But do review them, okay? All right, so that's basic. And the rest of the things is just, you know, I have 39B, 39C. These are more looking like calculus questions. Okay, not exactly calculus question with the calculus concept. It's a kind of algebraic form you're gonna work with in calculus classes. Okay, so I want you guys to have a, you know, to see this, to have a preview. So by the time you get into calculus class and say, hey, I've never seen this before. This algebra looks weird. Oh, surely they might look weird a little bit, right? Basic 40A, I would say on basic 40, right? Through, you can skip this. Okay, if you have done basic 40, you can skip for now. Okay, these things you're gonna encounter in Calc 2, and I'm sure at the time your professor will go over that with you, okay? Because if I taught that class, and I would just go over that with our student, you'll get it, okay? More function composition, right? Basic 41. We didn't spend too much time here, but because you guys, I think you guys know this. Basic 41 through through 42. Wait. 42. Some numbering issues there. Basic 42A. Okay, it's finding inversions that we done that. But most importantly, you're going to encounter immediately is basic 43A. 43A, right? How to decompose, right? So if these are about composition, right? Adding, right? This is about adding, subtracting, multiplying, dividing, right? Composing functions, f composite g, right? So this is f plus g minus g, f, you know, multiply, divide g, right? Composing, and 43A is about decomposing. Decompose functions. We did some exercise there, right? You guys got the hang of it. You just peel it layer after layer, like we peel tamales. Okay, like peeling tamales. All right, so, and yesterday we covered mathematical induction. Mathematical induction method. And your actual credit is on mathematical induction. Okay, on divisibility. So I pick one of the questions from 44B because this is extra credit. So we can afford to do something that's like, that's more fitting to that title. Okay, math induction. Okay, 3 steps. So when I examine your work, I want to see this step 1, 2, 3 clearly, you know, specified, logically presented. Okay, if you need to, you can watch the lecture about that section, okay, to do a good job. Okay, always show your best work. Always show your best work. And then we come to trig revisit. We didn't spend much time here at all, actually. Okay, so the second trig revisit. Okay, I'm gonna put it here, trig 12 through trig 12 through, these are revisit. Did we do the deriving of trig formula? I forgot. I think I might have given you some videos to watch, right? Deriving of the trig formula. I thought we did. I forgot already. Okay, so this part of trig questions, we didn't spend time, but you should be able to do it. Okay, a lot of these are just building your skill building. Okay, revisit. Okay, build skills. Building skills. Oops. Build skills. And trigonometry, you're gonna have a lot of trigonometry in Cal. I mean, the track you're going through, right? You're heading to Math 190, Math 191, right? So you need a good foundation. And for example, 24A, right? Such as 24A. I think we pick a couple exercises on 24A, right? 24A. Those will be typical questions that I made up. I think we did a little bit of trig 24A. For example, right? You're gonna take a derivative of some trig functions and then you have to reduce it. And you encounter something like that in trig 20, like in 24A. Right, you need to be able to reduce it. So you need to acquire some skills to reduce trig expressions. Right? So examples in trig 24A, okay, may be useful in Cal. Okay, just simplify, right? Simplify, and our preferred form, right? When we do a lot of simplifications, right? We get that statement, we simplify. Whether in statement or if statement cases, we want to reduce the form in factored form, in product quotient form. We now understand why we want them to be in product factor form. Hold on. I see a message in chat. I'm sorry, I've been ignoring. Okay, thank you, Cortland. Do you refer to the trig formula? I think so. Thank you. Thank you for pointing that out. I'm already forgetful, huh? Thank you for confirming that. Okay, thank you for confirming that. But anyway, so those skills, and as I encourage you guys at the time, I'm sure I did, is building your skill. Is building your skill. If you can derive all those formula yourself, oh, you're gonna feel so much more at ease. You have so many tools in your toolbox, and it's all in there, right? No one can take it away from you. No one can take it away from you. You're gonna feel great. Okay, you're gonna feel much more at ease. It takes work. It takes work. Your hard work will be paid off. Your hard work, this course will pay off for the following semesters. Okay, Calc 1, Calc 2, Calc 3. Okay, because you have a good foundation, algebraic foundation. Okay, that's what we try to build and re-enhance. Okay, we're trying to build and enhance. I think yesterday we covered parametric, right? The day before we covered mass induction. I'm sorry, I messed up. That was, so mass induction was the day before, which is a Tuesday. And we did yesterday parametric. Parametric. Okay, parametric 1. I don't have parametric 2. I don't have parametric 2. Okay, we don't have parametric 2. Just make sure you understand the lecture, right? And the more reductions, basic 45, these are more preparing you for, say, basics 45 and onward, right? You got more, these are more calculus-like algebraic forms, okay? 46 and so on and so forth, 45, 46, and 46, we have ABC, we have all these. If you want to start practicing for your calculus classes, go for it. Go for it, you got them, okay? And as you do them, you realize, oh, you know, you're getting better every day, okay? So I would encourage you guys, just don't stop practicing those, okay? And 40, all the way up to 49. Some of these questions we didn't really spend time, but those are just shifting left, right, up, down, and all of that stuff, right? And the next treatment we have following the order is the handling of piecewise functions, basics, 50A. Okay, the handling of piecewise functions. Okay, the handling of piecewise functions. Of course, we handle the piecewise function with the absolute value of x from the beginning, and we expanded that handling and how to graph piecewise functions and so on and so forth, and how to turn piecewise functions, how to turn absolute value functions in its various form to piecewise functions for your further study, right? So 50A, 51A. This part, you are going to encounter these functions as soon as you get into calculus 1. Okay, I promise you, okay? Too bad I don't get to teach that class next semester. Okay, not in the summer, I don't teach in the summer. And if you guys have any questions about your calculus class, if you take it in the summer, you can use me as a resource. You can send me emails and I will respond to your emails and I'll be happy to help you. Okay. I don't work in the summer, but I will be happy to help you if you take summer class or you take this fall class. I think I don't get the assignment for teach calculus, but I can help you with your questions if you want to ask me some questions about them. Okay. We didn't cover anything afterwards, I believe. From basic 52 through the rest of them, and the polar, we don't have time to cover polar. Polar will be something you will encounter. Okay, we have polar. Polar is something you will encounter. I think at the time your teacher will cover that in your calculus classes, and you can pick up. Okay, but still there's A, R, D. Somewhere embedded over there. Okay, so it's not exactly ARD, you'll find out, but there's some new rules and you will see traces of ARD there. Okay, you'll see traces of ARD there. So I'm not going to cover this section for you in this class. I'll just leave it for your calculus teachers. The next one that we didn't get to cover is sequence and series. Okay, we did not have time to cover. right? Polar, sequence, and series. It's too bad we didn't get to cover those, but if you like, you can read about it. You can read about it, okay? Series and sequence will show up in your calculus 2. Okay, but arithmetic sequence, I would say, will show up in calculus 1. If you study a little bit, because I have some material there, you can pick up a textbook to study. I think you guys probably can test drive your self-learning ability, right? Do something like that. And if you have any questions, use me as a resource. Use me as a resource. I'll be happy to help you with that. But I would encourage you guys to take the initiative to do that, to do some deriving, to study these, right? But otherwise, you're gonna get those in Calc 2 primarily. Chapter 11, I believe it's chapter 11, okay? Sequence and series seem to be rather difficult for a lot of students, okay? I wish I could cover more of I could prep you on this, but unfortunately, we just didn't have that much time. But if this notes can inspire you to get started to study a little bit, and you can totally do it. If I can help you in any way, just drop me an email. No problem. I'll be happy to help. So what are going to be tested, right? Because after all, you want to get out of this class with a resounding successful score and get into your next class, right? But don't stop practicing. So what are going to be tested? Well, only the materials I covered in class will be tested. Okay, I will only test you those materials that I have covered in my classes. So you don't need to worry about those other things, but you just need to understand, to fully prepare for your calculus classes. I mean, there's a lot more work you can do. But these are the things that you work on yourself. You don't have to work on someone else, right? You can just work on yourself. You work on yourself, you build that, and no one can take it away from you. You know what I mean? I don't know what time is it. 1 hour has passed. Shall we take a break? Yeah, let's take a break. Come back at 9. Come back at 9:15. Okay, it's around 9:05. Come back at 9:15 and we will continue. I would like to take your question. Okay, I would like to take your question. So let's take a break. Come back at 9:15. AM. Okay, we'll continue. With your questions, I'll be happy to answer your questions. Okay. All right. I will see you soon. I'm going to resume recording. All right. Let's see. Do you guys have any questions? Let me clean this. Is there any specific area? Okay, I would encourage you guys to, you have to start somewhere to review, right? You've done some, I'm sure you've done some review. I have made it available for you to see the past quizzes. Okay, to see the past quizzes. And these availabilities is only until the end of Tuesday, okay? June 8th. So I will have these quizzes available to you with the correct answers until June 8th, which is Tuesday next week. Okay, so I will be opening all of those for you to view all the way up to the 8th of June. As you understand that the quizzes, well, you cannot redo the quiz for better score, but you can review the quiz, look at the answers, So you're gonna see your answer as long as the correct answer, okay, as well as the correct answer. Okay, so make sure, maybe you want to start from there and look at the homework you've done, right? And look at the lectures, look at the review the lectures. But sometimes you can see the lectures can be overwhelming. There's a lot of lectures, right? There are lots of lectures. And I'm sure, I trust you guys probably have done some replay of those lectures. You know where to find them, right? You can view those lectures for sure. But sometimes you just want to say, oh, I just want to look at this quiz. Did I do well? What did I do wrong? Right? Why this is right? Why the other one is wrong? You want to know an answer like that. So look at the quiz would be a good place to check those. You know what I mean? So look at the quiz, and if you need any particular answer to anything, so please just don't hesitate. Okay. Yeah, I'm ready for your questions.
There's a question in chat.
Oh yes. I keep forgetting to check the chat. Thank you. Chat, can you pick a random question from the parametric problem? Could I pick up a random question? Oh, you can pick up a random question for me. How about that? You want me to pick up, Cortland?
Yeah, can you pick one?
Sure. So I'm going back to yesterday's lecture. So let's pick one random questions. Let me get there. I'm gonna look at my hard copy. Look at a random question. You want another trick question? We did number 18. We can try number 17. Want to try that? Okay, so this is the question I'm going to pick up. All right, so I'm going to put it right here. 17x equals to 5 times cosine t, and y is 2 times sine t. Right? And you also see the boundaries, right? You see the boundaries, and you can work this out. You know, you realize the boundary. Okay, that's what I always do. You know, you look at the function, and you can see the specific functions domain and range start to play a role into the analysis, right? And now it's a 5 times, so it's between -5 and +5, right? And sine is between -1. You see how those basic properties are being used, right? How those basic properties are being used. And those 2, and this is going to be -2, that's a +2. So your picture is going to be, so when you set up your rectangular system, right? When you set up your rectangular system, you know the x is not going to go beyond -5 to +5. The y's is not going to go beyond -2 to +2. Does that make sense? So here you already have a pointer that even though we're doing this parametric question, but we already have some reference about what? About the basic properties about trig functions, sine, cosine, their domain and range, right? Domain is any t, right? T can be any real number. And the range is between -1 and +1, and you can expand on that, and you get, your picture is going to be within this frame, right? Horizontally is going to be between -5 to +5. Vertically is going to be between -2 to +2. We'll not go beyond that, right? You see how much it helps us to analyze. Okay. So next you're going to plot some points. Right, we're gonna figure out how. So we're gonna plot the points. We're gonna have, let's see, 4 columns, maybe, rows. You know what? I'm going to salvage from what we did yesterday, right? The first one is a cosine. The second one is a sine, right? We did some work with the cosine, sine there, right? So we can rescue these tables. You also see the application of these special angles, right? They're used because they're easy to access. And they're just representatives. Okay? So here, where I rescue this table. Okay, I salvage this table. Of course, the function is different, right? This is 5 times cosine t. So this time it's a 5. So all of these are going to be 5 times, right? All of these are going to be 5 times, right? You see that? 5 times. So 5 times, 5 times. So you can rescue these tables. Okay, I do it because it's just saved me some time, right? So 5 times, 5 times. Okay, I don't really need the dots. It's probably, come on. Look at this is junk message. All right. And the sine is twice. Okay, so 2 times. So 2 times. Right? So you get these points, and of course, this is going to be 5 times, and this is going to be 2 times. Right? And so 5 times. So you can just put them in place. So this is going to be 5, and this is going to be 1, and this is going to be 5 times, and this is going to be 2 times, right? 2 times, so that you just have root 2 left. You know what I mean? You pick some special angles, and then here, this is going to be 5, 5.5, and this is going to be 2, so this is going to be just a root 3. Right, root 3. And this is 5. 5 times 0 is still 5. This is going to be 2, right? So this is going to be 5 times. So hold on. The key we want to do, you just want to choose a couple of points to know the direction, so you can mark your arrow, right? So you can see the trajectory. And you also see that, you know, the table we did is very limited, right? You should do T from, you should do more circles, right? You're going to see it's going to be around it. It's going to be around it. Okay. So now say here is a -5/2, and this is going to be 2. So this is going to be √3 again, right? √3, and this is going to be 5. And this is going to be √2, right? And you can see the calculation. The numerical part shouldn't be too hard. And that's your basics. That's your basics. So this is 1. So this is a -5, and that's 0. So all the points are in place. So let's start plotting, right? Let's start plotting. This point, you just have to start from somewhere, right? So make it a red dot. Right, this is one red dot, right? You may like to mark that point on your picture, right? And the next one, you're gonna plot it in your picture. Estimate. Okay. The next dot, right? One is at 1, one is at 2. So the arrow should move from, how does the arrow move? How does the arrow move? Yeah? This direction, right? So it's a clockwise, right? And keep going, keep going. The next point. Oh, wait. No, I marked it wrong. I'm sorry, I marked it wrong, guys. I marked it wrong, okay? 1 √2 √3. It should be this way. Clockwise, counterclockwise. Okay, because this is at level 1. You see, that's important to mark the points, right? It's important to mark the points. When you mark the points, you will know from where to where. So this is a counterclockwise, okay? And of course, the next point, you're gonna have 0, 2. Right, you're gonna have 0, 2. At the point 0, 2 right there, 0, 2, right? So it's a counterclockwise. Okay, counterclockwise. And we know this is an ellipse, right? We know this is an ellipse, do we? Right, we use the same technique to decide this is gonna ellipse. And so the points is gonna go down this way and keep going, circular motion. This is like, you know, a trajectory of a particle. Okay, trajectory of a particle. Got it? Yeah? Algebraically, how do we identify the curve? Did you guys get the technique? Right? So we basically have x equals to 5 times the cosine t, y equals to 2 times sine t. So to make a t disappear, what you can do is that you can divide both sides by 5, right? So x over 5 equals to cosine t. And the next one is that y divided by 2 equals to sine t. This would be considered a peanuts, peanuts trick, right? Peanut trick, right? And then you're gonna do the x squared. You're gonna square both. Whoops. Right here, squares plus. These techniques, peanuts. It should be peanuts for you. Okay, so cosine square t plus sine square t. You see that basic identity in trigonometry is used, right? You see that? And then we got t disappeared. This is an ellipse. This is an ellipse. Okay, in particular, you want to write it down this way. Okay, 5 squared. This is a standard form of ellipse, right? You guys, well, conics is another section we didn't get to review. If you want to review that part, you have any questions, and you can ask me. Okay, so that's ellipse. Okay, that's the ellipse. So if you draw this circle, if you draw the ellipse, you can draw the ellipse. Okay. So we're gonna have the y will equals to square root 1 minus x squared divided by 25 times 2. Right, that's the first half. And the next half. Lower half. Right, that's that 2 functions right there. So you're gonna have the points, and the points is gonna be this way, this way. That's a counterclockwise. So if you imagine there's a particle, the particle is traversing, this particle starts somewhere, is going to go counterclockwise at different time. Time pi over 6, time pi over 4, even though we're not quite used to it, right? Pi over 6, it's just a number. It's just a number that time since the beginning. Is that helpful, Cortland? Get it? Right, parametric.
I got it now.
Hmm?
I said I got it now.
Good, good, right?
Thank you.
So along the way, you can see we use some special points, right? We can use some special points. And let's plot this point just to conclude, right? Just to conclude this question, just to show you another half, right? -5, 0. So I'm gonna add another point, -5, 0. Right, so that point. Ooh, all these points are plotted for us, right? You could let that happen, but I didn't intend it for that. Wait. Let's do the line for me. Huh. Black line. Okay. And add another point. My bad. Totally my bad. There. right? So the point goes counterclockwise. Okay, if you keep choosing t, you can choose arbitrary values, but it's just easier to choose a special value, isn't it? It's just easier to choose a special value. You don't choose like 0, 1, 2, 3, 4. That's going to make a hell of a lot of calculation you don't want to deal with, right? Because we can choose any t, so we choose some special t, right? Because we can choose any t, so we choose some special t. All right, so that's parametric. That's parametric. Okay, any other questions? You want to practice your algebraic skill. I have said this many times, right? I remember this experience when I was in graduate school. At the beginning, I didn't know how to drive, right? I mean, driving is something you have to practice, right? Otherwise, you know. So I remember I saw this guy when I know him. He was driving. He's probably a very good driver. The car in his hand that he was driving, it's more like he's driving a toy car. Very experienced, all right? He just left, right, and very smoothly. How do you get to that good? You probably have drive a lot, right? Drive a lot. So algebra is the same thing, right? You master the basic principles and you're aware of those basic principles. And there's only just so many techniques, okay? I think we have touched all the techniques. I give you some rule of thumb when deal with exponents, right? Especially negative exponents. I want you guys to remember those rule of thumb, okay? It will serve you. It will serve you, right? See how we make one, right? Those techniques, right? Conjugate and multiply by 1, anything times 1 stay the same, right? So don't forget those, right? So what I meant is that anything times 1 stay the same. You could have omega over omega, that's 1, right? That's one form of 1. Another form of 1 is omega to the power 0. It's also equals to 1, provided omega is not 0. Very basic, right? And that rule of thumb, when you reduce things like basic, I forgot, it's basic 46 or something like that. Basic 46, right? You reduce those weird looking algebraic form you get after taking derivative. I know you guys can do it. You do well. Okay, you follow me this whole semester, right? I touched a lot of aspects when I wish my student knew when I was teaching Cal. Okay. And so I was always mindful with that perspective that my students are going to take calculus classes. They're going to encounter this and this and that. So I'm being mindful of that. So I hope that will help. Okay, I hope that will help. So just keep on practicing. So let me take some more questions from you. Yeah, please.
Could we go over trig 24?
Trig 24. Sure. Trig 24. Do you have a specific question? Let me find it. Okay. Trig 24. It's one of those reducing, right? Am I right?
Yeah, it says simplify that is final answer and product and or quotient.
Okay, so let me find that question. Do you have a question you want me to do? Which page is this for? Can you prompt me?
121.
121. Yeah, 121, trig 24. So I'm sorry, which one do you have in mind?
I guess just number 1. I just wanted to kind of like review what it's all about.
Okay. Okay. All right, we got 3 cosine x minus 3 times sine square x multiply cosine x, right? Typically, okay? I know how I got these questions. I basically went into calculus class, the calculus textbook in the specific questions, and I took the derivative, right? And then I expect the student will reduce. When you reduce, what kind of form do you reduce to? Typical one, you want to reduce it to product form. Product form. Then you say, why product form? Why product quotient form? Principle number 5, number 6, right? So this is gonna give you sine square of x, right? And then you know the rest, right? It's just 3 times the cosine x, and 1 minus the cosine square x is a cosine. 1 minus sine square x is a cosine square x. So in the end, you have a 3 times cosine to the power 3x. You're done. You see some very basic tricks. Not even called, I don't think there should be called tricks, right? Very basics. Do you want me to take another one for you?
Yeah.
Say number 7. Would that sound interesting to you?
Yeah.
So number 7, you have 2 plus, let me make the fonts larger, right? I like larger fonts, do you? So make it easier to see. Okay, minus a cosine x, cosine x. Denominator 2 plus sine x squared. Right, how do we reduce this? Well, you want to, right? Cosine x times cosine x, that's cosine square x, right? On this piece, you're gonna distribute. So you're gonna have 2 times negative sine x, that's negative 2 sine x, right? And sine x times negative sine x, that's gonna be a minus sine square x, right? And then one step further, right? One step further, you can factor out the negative signs in here, right? You can factor the negative sign over there. So you factored out the negative sign in between these two terms. You're gonna have a negative of sine x squared plus that. And the rest, you just apply that 1. So this guy equals to 1. Simplified, factor form. Okay, you have a quotient, you have a denominator. Denominator will never be 0. You don't have to worry about it because sine is what? So when you analyze this form, right? The domain is all real numbers if you think about domain, because sine x is between negative 1 and 1. So 2 plus sine x is always going to be what? It's always going to be at least what? Right? So if you analyze this expression, right, in terms of domains, right? And it's all real numbers. Why all real numbers? Because you know sine x is between negative 1 to positive 1. So when you add 2, right? When you add 2 and where do you end up? So this is where the basic knowledge is so important. You follow me? So your denominator here is always between 1 and 3, 1 squared and 3 squared. So you never have to worry about having a 0 denominator. And numerator can be anything. Therefore, the domain is all real numbers, right? And you might encounter, say, hey, what if this is 0, right? So you're gonna set it equal to 0. For example, I will give you a number of scenarios that you might encounter this, right? So for example, you're gonna set this denominator equal to, you're gonna set the whole thing equal to 0, right? You have an if statement, that's the typical, that if this is 0, denominator will never be 0. So the numerator will have to be 0. Right? And then you're gonna end up with sine x equals to negative half. What kind of question is this? This question becomes what? I'm just elaborate a little bit, right? Just thinking about your calculus setting. That's a trig 11a or 10a, something like that. Right? You solve this trig equation, ARD, right? So now you know D, you're trying to get A. Right? Remember ARD? Right? ARD. Right? So you basically know D, you want to get to A. Right? This is definition given. So you're going to figure out the R and then you get the A, because A is the angle. You're looking for X. X is in place of angle. Right? So all that input output we're talking about, which one, what kind of input is expected? What kind of output is expected? They're all there. Right? Okay, let's try another one. Say number 8. What do you like? How about number 8? We have complex fractions here. Yeah, that happens, right? You have sine x minus 2 plus sine x minus 2, sorry, minus 2 plus 1 over sine x. Okay, now you have a sine x minus 1 over sine x. How are we going to reduce this guy? Right? Common denominator. Sine x over sine x. Right? So you take the sine x on the top and multiply each one. And you take the sine x in the bottom to multiply each term in the, so this is a, so you take the sine x, right? You multiply that. You multiply that. And you multiply that. And then you take the sine x in the denominator to multiply that. And you multiply that. Then you reduce it. You reduce it, right? What you get, sine x times sine x, that's a sine x squared, right? So sine x squared minus 2 sine x, and this makes 1, right? And this makes sine square x, sine square x, and over here is 1, right? You guys see that? And what is this guy? The top is a perfect square. The bottom, what is the bottom? Knowing what you have on the top, right? The bottom is sine x minus 1 times sine x plus 1. You follow me? So what is this form? What is this form? The form on the top, is basically it's omega squared minus 2 times omega plus 1. That's a perfect square, isn't it? Right? It's a squared plus 2ab plus b squared. You see how these basic things, they just show up here and there? Do you guys follow me? Yeah, do you guys see that? The bottom, of course, you can change it to negative cosine square, but you can also, knowing what you have on the top, you have that flexibility to factor out that's going to be a squared minus b squared. Right? Because 1 is 1 squared. And now you can reduce these two, right? So in the end, you're getting what? What are you getting? You're getting this one is reduced and one of that is gone. That's what you're getting. And of course, provided, because you're reducing that, right? Sine x sine x cannot equals to 1. Right, so you need to, because otherwise you cannot reduce. Right, so this is the factor form. Right, so from there, we go through complex fractions and then apply some factoring techniques, right? And sometimes you encounter those special formula. Sometimes we encounter those special formula, right? So this is what I said. Everything you learn in elementary algebra, those x, y, z's, they turn into baloney. And here the baloney is sine x, right? The baloney is sine x, right? If you recognize this two, if you recognize this, right, which is x minus 1 squared, then you would recognize that. It just takes some practice to recognize that. I don't know if there's any other way to do it, right? It's like you drive on the road or you're shooting the loops, you're playing basketball. You just keep doing that. And so eventually the basketball probably become like a toy for you. You can throw it anywhere you want. I think math is comparable with that. It's built by you. That foundation is your foundation is built by you, no one else. Right? Does that make sense to you? You can see how much basic things being touched. Right? Basic trigonometry, some algebraic. Then you say, how do you know that? Right? Enough practice will get you there. Okay, there's nothing mysterious about it. As I told you, I'm first generation college. Okay, my parents could help nothing about my study. If I can do it, anybody can do it. Right? If I can do it, anybody can do it. No calculator. When I was studying math, no calculator, no computer, just a piece of paper pencil. That's all I have. That's all you need. And of course, the willingness to do it. You guys can totally do it, right? You don't need to buy new paper. You just, these days people recycle papers, right? There's too much paper. You don't need to cut down new trees. You know, you get a paper pencil, you get it. If you're strong in math, you're strong in computer, you're strong in English, you can go anywhere. Okay, if you have a strength, you have some strengths in math, you have some strengths in English, okay, you study some coding, because if you're strong in math, coding is a piece of cake. You learn it, you can go anywhere. You will go anywhere. Okay, you can see, look at these days. You know, I heard people who are, I was just talking to a friend last weekend. Her nephew just get a computer science degree to software engineering. They have 20 positions. They cannot find enough people to fill them. How much they get paid? At least 100K. Higher than my salary. I've been working for 20 some years. Okay. Right, easy. All you have to do is just be strong in math. No, I mean, you don't have to be terribly strong in English. I mean, decent in English. English is your native language. Learn some coding, and the company can't. They can't find out enough people. You have a beautiful, you know, you have a nice paying job. Be good at math, okay? And you can do it. And I couldn't emphasize enough. This summer, you guys study math. Don't forget about me. I'm here to help you. Anytime. I had a former student come back to me to ask me questions. I'm happy, I'm delighted, I'm flattered. Free. You make me happy. You made me proud. How about that? That's all I need. You make me feel useful. And I want to see you success. Okay? If you have tolerated my abuse this semester, right? You have a good study habit. You are making it. You're making your way to wherever you want to be. You just have to get that mass. You do. You do. You need that. Okay? Oh, thank you, Cortland. But you stick with me, you know, thick and thin, right? Do you regret? You've done it? Have you learned something? But most of all, I want to encourage you guys to start to nurture your ability to learn things on your own. That's important. Okay? So a promise is a promise. I hope someone will come to look me out, to reach out to me, say, hey, Professor Wang, I have this question. Oh, I will be so happy to answer your question. Okay, forget the tutors. Forget the tutors. I'll be happy to help you. I'll be very happy to help you. Okay? Okay. But anyway, I want you guys to keep on practicing. I want you guys to make that grade, get that nice paying job. The rest is history. The rest is history. Okay. More questions? Keep on deriving. Keep on deriving, okay? You can do it. You're already doing it. If you sustain this long with me this semester, thank you for, you know, allowing me not to call it abuse. You can do it. You can do it. You can totally do it. Totally do it. Okay? So I will see you guys on Monday. Remember, we have class on Monday, Tuesday, and your exam will be available Monday through Friday. Okay, I'm opening the past quizzes to you until Tuesday night. Okay, after that, will be closed. The quiz and exam, the midterm exam will be closed, the past one, but you still have the lectures and stuff. Okay, any question, I mean any question, anytime, you please reach out to me, okay? Inbox, pronto, text message, all right? You don't bother me, you never bother me. I'm only happy to hear from you, always. And you just promise me you're gonna make that grade and get that fabulous job, okay? All right. I'll see you guys on Monday, if not sooner, okay?
Thank you.
Thank you.